In this first problem, we want to find the volume of this rectangular solid. So let's draw a rectangular solid. Looks like this. And here's what we're given as the dimensions. We have the width is 15 millimeters. Now, who knows for sure what the width is? I'll call it this one. 15 millimeters. The length is maybe 28 millimeters. And the height is 3.5 millimeters. And for rectangular solids, we have a formula for finding the volume. It is V for volume, length times width times height. Let's put these numbers in and see where it takes us. So we're going to get the length. Now, it doesn't matter what order we put these in, but I'll do LWH. 28 millimeters, width 15 millimeters, and the height 3.5 millimeters. And now I'm going to multiply these numbers together. So when I multiply those numbers together, I get V equals 1470. And then when I multiply the m's, millimeters, mm times mm is mm squared, mm cubed, right? Mm times mm is mm cubed. So we get the volume is 1470 cubic millimeters. So it's about the same thing in number 2. We want to find the volume of this rectangular solid. So it's going to be the length times width times height. So how about 14 centimeters times 4 centimeters times 2 centimeters. And this is going to give us a total of 112 cubic centimeters. Cubic centimeters. Let's get that right. Cubic centimeters. So I got the 112 from here. 14 times 4 times 2. And the cubic centimeters from centimeters times centimeters times centimeters. Let's get the volume of this cube. Now I know it's a cube because length times width times height is all the same. So it's a cube, rectangular solid, but it's a cube. So what we can do is we could use this formula. Volume is equal to length times width times height. But since they're all the same, we could just say the volume is equal to one of the sides cubed, right? It's like a side times a side times a side, s cubed. So we're going to get that the volume is equal to 2 inches. Now, you could do 2 inches times 2 inches, or just because they're all. Now here in number 4, we have a cylinder, and the volume of a cylinder is given by this formula. V equals pi r squared h. Now, the cylinder I've drawn is called a regular cylinder because it just goes straight up. It's got a circular base, and it goes straight up. So this is pretty common for a volume of a regular solid, is that you take the area of the base. What is that? That's the area of a circle right there, times the height. So we are going to get here that the volume is equal to 3.14 times the radius, 8 meters, squared, times the height, 6 meters. So making this computation, we'll get the volume is equal to 3.14 times 64 square meters times 6 meters, or you can just do it all at once on your calculator if you can do that. And I'm going to get 1205.8 cubic meters. Now in number 5, this is similar to 4, but in 4 we were given the radius of the bottom there, and this time we're given the diameter. So what we're given in this problem is that the diameter is 15 meters. So from here to here, it's 15 meters, and the height here is 12 meters. We are given a cylinder again, but in this time we're given the diameter of the top. Back in problem 4, we were given the radius, and we still used our formula here because we had the radius directly. Now we're given the diameter. But we can still use our formula. The volume is equal to pi r squared h. Now, what is the radius? Well, the radius is half the diameter. So if we take 15 meters and divide by 2, we'll get 7.5 meters. And then substituting in, we're going to get the volume is 3.14 times 7.5 meters squared times the height, which is 12 meters. And this time when I computed, I got 2119.5, 2119.5 cubic meters. This is a pyramid here in number 6, and what we're given is these dimensions. The base of this pyramid, so the base, here's the base, we're already given that the base has an area of 3,600 square feet. And we're given that the height is 54 feet. So the height, that's going to just drop it down. That's 54 feet. Now, maybe you remember what we talked about back over here in number 4 with a cylinder. This is a regular solid, and it's typical in a regular solid, you get the volume by taking the area of the base, circle in this case, times the height. Now, look what we have over here. We have a pyramid. That's a regular solid in this case. So we have the area of the base times the height. So this volume is going to be the area of the base times the height. So we're going to get 3,600 square feet times 54. Let me see if I can actually write that. Times 54 feet. And if I multiply these numbers together, I'm going to get 64,800, and feet squared times feet gives us feet cubed. So now we've got a cone, and the radius of the base here is 7 meters, and the height of the cone is 2 meters. Well, I didn't draw mine to scale, but it doesn't matter. We have the numbers. Now there's a formula, a volume formula for a cone, and it goes like this. The volume of a cone is 1/3 pi r squared h. Pi r squared h. Okay, so look at this for a moment here. Remember this one here, pi r squared h? That was the volume of a cylinder, but we have 1/3 of that. So if you take a cone and put it into a cylinder, it would take up 1/3 of the cylinder. But let's put our numbers in here. So we're going to have that the volume is 1/3 times 3.14 times the radius squared, 7 meters squared, times the height, 2 meters. All right, now I just did this on the calculator. I put in this. I put in 1 divided by 3 times 3.14 times 7 squared times 2, and that got me to 102.6, and this cubic meters, right, because what we have here is square meters and meters, cubic meters, and I did round off. I rounded this off to the nearest tenth. And just in case you wanted to know what I really rounded off, when I really computed, I got this. I got 102.5733 ... forever. But it says to round off to the nearest tenth. So I rounded here. Now we've got a sphere, and we want the volume of the sphere, and we're given that the radius here is 8 yards. So we have a formula for the volume of a sphere, and it goes like this. It's 4/3 pi r cubed. So if we put our numbers in, we're going to get V equals 4/3 times 3.14 times 8 yards cubed. And I'll put this in my calculator like this. I'll put it in as 4 divided by 3 times 3.14 times 8, up arrow, caret, 3. I get 2143.573333 and so on. But it says to round to 1 decimal place. So if we round to 1 decimal place right here, that's a 7. We'll round that up to a 6. So we're looking at this for the volume. 2143 0.6, and then cubic yards. So in 9, we're given a sphere again. We want to find the volume. But back in 8, we were given the radius. Now in 9, we're given the diameter. But we know that the radius is half the diameter. If we're going to use this formula here, we need the radius. So we're going to use this formula, V equals 4/3 pi r cubed. So we're going to have V equals 4/3 times 3.14 times, now, this is the radius. We're given the diameter. The diameter is 18. The radius is half of that. So this is going to be a 9 inches. So we're going to have 9 inches cubed. Now, computing on my calculator, I got 3052.08 cubic inches. And it just says to round off to the nearest integer. Now, that's the nearest integer. To the right is a 0. So I'm just going to drop these and write this volume as 3052 cubic inches. And just so you know, the way I got that on my calculator, I did this. I did 4 divided by 3 times 3.14 times 9 cubed. What we want to do here is we have 8 cubic meters, and we want to convert this to some number of cubic millimeters. So cubic meters to be converted to cubic millimeters. I think we might think of doing something like this for this problem. We know that 1 meter is equal to 1,000 millimeters. Now, if we remember, here's our line. If we put ourselves right here at meters, we would have to go 1 to deci, 2 to centi, 3 to milli. Deci, centimeters, millimeters. So if we take our 1 meter, we would have to take the decimal point 1, 2, 3 places to the right. So we're going to get 1, and then 1, 2, 3 places to the right, millimeters. And now, 1 cubic. If I cube this side, I'm going to cube this side. And this will give us, it turns out to be, if you take 1,000 times 1,000 times 1,000, you get 1,000,000,000 cubic millimeters. So I'm going to do this up at the top. I kind of squeeze this in here. Here's where we are. We're at 1 cubic millimeter is equal to 1,000,000,000, 1, 2, 3, 1, 2, 3, 1, 2, 3 cubic millimeters, but we want 8 of these. So let's just multiply both sides by 8. That'll give us 8 times 1 is 8, 8 cubic millimeters, 8 cubic meters, and multiply the right side by 8, multiply this side here by 8, we'll get 8 billion. So 8, 1, 2, 3, 1, 2, 3, 1, 2, 3 cubic millimeters. That's how we could make that conversion. What we're looking at here is trying to figure out how many of these cubes, these 1 centimeter cubes, could we put in this big block over here. Well, let's find the volume of this, and then we'll see. So this thing here is a rectangular solid, and we know that the volume is the length times the width times the height. So the volume here is going to be the length, maybe that's 7 centimeters, times the width, 8 centimeters, times the height, 5 centimeters, cms. And when I make that multiplication, and now look back here, what is this? This is 1 times 1 times 1. That's 1 cubic centimeter. And how many can we put in here? Well, 1 will go into 280. You know, this is making it harder than it seems, but I have this. I have 280 cubic centimeters. How many times will 1 cubic centimeter divide into that? Cubic centimeters divide out, and we're left with 280. So I get 280 of those cubes. In problem 12, we're given that we have a stone pyramid with a square base. So I drew this pyramid, and I made a square base here. And here's what we're told. It has a square base that measures 148 meters on each side. So this must be 148 meters. This is 148 meters. And the height is 87 meters. So the height from the top of the pyramid down to the base, that height is 87 meters. Now we have a formula for the volume of a pyramid. The volume of a pyramid is equal to 1/3 BH, where this B right here, that's the area of the base. So we know this. The volume is equal to 1/3. Now look at the base. We're told the base is a square, so it's just this side times this side, or 148 square meters. So it's 148 meters squared, right? Length times width, they're the same, times the height. And the height here is 87 meters. So I'm going to put this into my calculator just like I see it. 1/3 times 148 squared times 87, and that comes out to be 635,216 cubic meters. I'll put a comma in here to make it a little easier to read. Now we're given that we've got a tennis ball here in problem 13, a tennis ball, and we're told that the diameter is 6.54 centimeters, and we want to find the volume. So what we have here is a sphere. So we need to find our formula for the volume of a sphere, and that formula is V equals 4/3 pi r cubed. But now the formula has a radius in it, not a diameter. We're given the diameter. So we do know this, though, that the radius is equal to the diameter divided by 2. So 6.54 divided by 2, that is a 3.27, and it's all in centimeters. So let's substitute now. We're going to get the volume is equal to 4/3 times 3.14, that's our approximation for pi, times 3.27 cms cubed. Right, I'll write it like this, 3.27 centimeters cubed. So I'll put it into my calculator just as I see it. I'm going to put in as 4 divided by 3 times 3.14 times 3.27 caret 3 cubic. And my calculator is showing that the volume is going to be 146.3900, a bunch of numbers out here. But what we're asked to do is just write it as an integer or a decimal, but round to the 100th. Round it as the 100th. Well, the 100th is right out here. Okay, so the number to the right is a 0, so just going to leave it as a 39. So let's write our volume then as 146.39 cubic centimeters. Now what we want to do is find the difference in the volume between a baseball. So we have a baseball here and a soccer ball. So we've got two spheres. We just want to find the difference in the volumes. So we have a formula for the volume of a sphere, right? We just use that as 4/3 pi r cubed. Now, how about if we do this? What I want is the difference in the volume. So I think the volume of the soccer ball is going to be bigger. So it's going to be the volume of the soccer ball minus the volume of the baseball. But notice in our formula, we've got an R, not a D, and we're given D's up here. So we need to get these two radius. So here's the radius of the baseball. That's going to be the 5.75 divided by 2. So 5.75 divided by 2, that's 2.875. And the radius of the soccer ball, that's going to be 9.50 divided by 2, and that comes out to 4.75. Now let's substitute in. So we'll put in here for the soccer ball, here for the baseball. So for the soccer ball, we're going to get 4/3 times 3.14 times, now the volume, the radius of the soccer ball is 4.75 inches cubed, minus, now for the baseball, 4/3 times 3.14 times this radius, 2.875 inches cubed. So I'm going to compute each one separately. For the soccer ball, I'm getting this, 448.6929 minus, and now for the baseball, I got 99.49057 and when I make that subtraction, I got 349.2023 but we're asked just to round off to the nearest integer. Now the nearest integer is right here. To the right is a 2, so we'll just drop that and we'll write 349. So the difference in the volume is 349 cubic inches.